Okay, so good day everyone. So this time we're going to discuss about chapter 5, no? That is emerging technologies in information technology infrastructure. So after you finish this chapter, no, you should be able to describe the components of IT infrastructure in detail, determine the stages and technical factors driving the development of IT infrastructure, and which computer hardware systems are now most in demand and what are the most current trends in software platforms. So, through the construction of 21st blueprint of strategic vision to become a world-class building in the knowledge age, no, the expanded use of IT is essential for the government, no, to achieve its goal, partly due to the symbiotic relationship between technology and knowledge. So in different sector that relies on knowledge, no, organizations must undoubtedly use technology to increase productivity, cut costs, and raise the caliber of their goods and services. The government agency must concentrate its effort on creating a portfolio of IT infrastructure initiatives that will give companies and other organizations the tools they need to optimize information utilization, improve business activity, and achieve and maintain a competitive edge. No, since its inception, there are certain projects now that has advanced significantly to become a significant IT venture because building and construction business process are being re-engineered with the help of national development and building a construction. So authorities effort of the significant increase turnaround time, productivity, and quality. So to give us more details about the topic, let us all welcome our presenter. Go ahead, ma'am.
Good day, everyone. This is Daphne Joseph P. Salazar, and I will be presenting Chapter 5, IT Infrastructure and Emerging Technologies. After this discussion, you will be able to answer the following questions. Here are the learning objectives. What is IT infrastructure and what are the stages and drivers of IT infrastructure evolution? What are the components of IT infrastructure? What are the current trends in computer hardware platforms? What are the current computer software platforms and trends? What are the challenges of managing IT infrastructure and management solutions? Chapter 5 1. What is IT infrastructure and what are the stages and drivers of IT infrastructure evolution? We define information technology infrastructure as the shared technology resources that provide the platform for the firm's specific information system applications. An IT infrastructure includes investment in hardware, software, and services such as consulting, education, and training that are shared across the entire firm or
Din, okay na po.
Dean, parang wala pong naka-assign sa chapter 6. Pero wala po yata kaming kilalang Neil Balba.
Sino yung ating next presenter? Ah, sharing pa lang po. Ayan na. Wait lang, sir. Okay, naka-modular kasi si Dr. Neil Balba, no? Play ko na lang muna yung video presentation. Okay, so this time what we're going to discuss about foundation of business intelligence, yung BI na tinatawag natin, databases and information management. So after completing this module, no, you should be able to answer the following questions. So what are the problems of managing data resources in the traditional file environment, and how are they solved by a database management system? Number 2, what are the major capabilities of database management system, and why is a relational DBMS so powerful? Number 3, what are some important principles of database design? Number 4, what are the principal tools and technologies for accessing information from databases to improve business performance and decision making? And last, why are information policy, data administration, and data quality assurance essential for managing the firm's data resources? Okay. Now, users receive reliable, timely, and pertinent information via an efficient information system. Information that is accurate is error-free when information is accessible to decision makers at the appropriate time. So it is timely. So when information is applicable and suitable for the task and choices that call for it, it is said to be relevant. So it may come as a shock to you to find that a lot of firms lack timely, accurate, and pertinent information because their information systems data has not been properly managed and maintained. Data management is crucial because of this. No? And of course, our presenter will be able to discuss how information system organize data in a computer files and conventional file management techniques to better comprehend the concern. Okay? So to give us more details about the topic, let us all welcome our presenter. Go ahead po.
Good morning, Dean Mello. Good morning, everyone. Today I'm going to discuss about foundations of business intelligence, databases, and information management. During the time of the pandemic, many businesses deemed it important to maintain and establish a good database system, especially that many opted to adopt digitalization in their business processes. The topics that I will be covering are organizing data in the traditional environment, the database approach to data management, and using databases to improve business performance and decision making. But before I proceed, let us get to know about the BASE Systems. BASE Systems is the United Kingdom's largest manufacturing company and one of the largest commercial aerospace and defense organizations in Europe. Its high technology, information-driven products and services range from one of the world's most capable multi-role combat fighters the Eurofighter Typhoon to the Jetstream family of commercial aircraft, to the provision of information technology and information systems for e-business to develop and implement logistics. Accessing the data from the many systems was a complex task involving many technical challenges. As the aircraft business of BAE grew, so did the likelihood for delays in producing the aircraft assembly, reports, and other operations data sets necessary for aircraft production management and decision making. What BAE needed was a single repository for CAD/CAM data that would also facilitate the integration of data held in its legacy systems. The company decided to replace its legacy system with an enterprise-wide knowledge management system which would bring the design and manufacturing of data into a single database that could be concurrently assessed by the design and manufacturing engineers. BAE implemented Siemens Teamcenter product lifecycle management software and Dassault System CATIA CAD/CAM software. The new solution has produced significant cost savings at BAE in terms of its design and manufacturing data management storage, while boosting performance. The experience of BAE system illustrates the importance of data management. Business performance depends on accuracy and reliability of its data. The company has grown its business, but both operational CAD/CAM efficiency and production management and decision-making were impeded by data stored in legacy systems that were difficult to access. How business store, organize, and manage their data has a huge impact on organizational effectiveness. Organizing data in a traditional file environment. An effective information system provides users with accurate, timely, and relevant information. Accurate information is free of errors. Information is timely when it is available to a decision maker when it is needed. Information is relevant when it is useful and appropriate for the types of work and decisions that require it. Let us first familiarize ourselves with the different file organization terms and concepts. A computer system organizes data in a hierarchy that starts with bits and bytes and progresses to fields, records, files, and databases. A bit represents the smallest unit of data a computer can handle. A group of bits called a byte represents a single character which can be a letter, a number, or any other symbol. A grouping of characters into a word, a group of words or complete number such as a person's name or age is called a field. A group of related fields such as the student's name, the course taken, the date, and the grade comprises a record. And a group of records of the same type is called a file. A record describes an entity. An entity is a person, place, thing, or event on which we store and maintain information. Each characteristic or quality describing a particular entity is called an attribute. For example, a student's ID, number, course, date, and grade are attributes of the entity course. The specific values that these attributes can have are found in the fields of the record describing the entity course. As I've mentioned, a computer system organizes data in a hierarchy that starts with a bit, which represent either a 0 or a 1. Bits can be grouped to form a byte to represent one character, number, or symbol. Bytes can be grouped to form a field, and related fields can be grouped to form a record. Related records can be collected to form a file, and related files can be organized into a database. So here is an example of traditional file processing. The use of a traditional approach to file processing encourages each functional area in a corporation to develop specialized applications. Each application requires a unique data file that is likely to be a subset of a master file. These subsets of the master file lead to data redundancy and inconsistency, processing inflexibility, and wasted storage resources. We have always been used and accustomed to the traditional filing system. But what do you think is the downside of a traditional file environment? Let us look into the different problems with the traditional file environment. In most organizations, systems tended to grow independently without a company-wide plan. Accounting, finance, manufacturing, human resource, and sales and marketing all developed their own systems and data files. For example, the human resources functional area might have a personnel master file, a payroll file, a medical insurance file, a pension file, a mailing list file, and so forth until tens, perhaps hundreds of files and programs existed. The resulting problems are data redundancy and inconsistency, program data dependence, inflexibility, poor data security, and an inability to share data among other applications. First is what is data redundancy and inconsistency? Data redundancy is the presence of duplicate data in multiple data files so that the same data are stored in more than one place or location. Data redundancy occurs when different groups in an organization independently collect the same piece of data and store it independently of each other. Data redundancy wastes storage resources and also leads to data inconsistency where the same attribute may have different values. Third problem that would arise is program data dependence. Program data dependence refers to the coupling of data stored in files and the specific programs required to update and maintain those files such that changes in program require changes to the data. Another problem is lack of flexibility. A traditional file system can deliver routine scheduled reports after extensive programming efforts, but it cannot deliver an ad hoc report or respond to an unanticipated information requirement in a timely fashion. Next problem would be poor security. Because there is little control or management of data, access to and dissemination of information may be out of control. Management may have no way of knowing who is accessing or even making changes to the organization's data. And finally, lack of data sharing and availability. Because pieces of information in different files and different parts of the organization cannot be related to one another, it is virtually impossible for information to be shared or accessed in a timely manner. If users find different values of the same piece of information in two different systems, they may not want to use those systems because they cannot trust the accuracy of their data. Hence, there is a need to be able to manage and store data efficiently and effectively. The database approach to data management. Database technology cuts through many of the problems of traditional file organization. A more rigorous definition of a database is a collection of data organized to serve many applications efficiently by centralizing the data and controlling redundant files. A database management system, or the DBMS, is a software that permits an organization to centralize data, manage them efficiently, and provide access to store data by application programs. The DBMS acts as an interface between application programs and the physical data files. The DBMS relieves the programmer or end user from the task of understanding where and how the data are actually stored by separating the logical and physical views of the data. The logical view represent data as they would be perceived by the end users or business specialists, whereas the physical view shows how data are actually organized and structured on physical storage media. The database management software makes the physical database available for different logical views required by the users. How a DBMS solves the problems of traditional file environment. A DBMS reduces redundancy and inconsistency by minimizing isolated files in which the same data are repeated. The DBMS may not enable the organization to eliminate data redundancy entirely, but it can help control redundancy. The DBMS uncouples programs and data, enabling data to stand on their own. So here is a classic example of how a human resource database looks like. A single human resource database provides many different views of data, depending on the information requirement of the user. Illustrated here are two possible views, one of interest to benefit specialist and one of interest to a member of the company's payroll. Relational DBMS. Contemporary DBMS use different database models to keep track of entities, attributes, and relationships. The most popular type of DBMS today for PCs as well as for large computers and mainframes is the relational DBMS. Relational databases represent data as two-dimensional tables called relations. Tables may be referred to as files. Each table contains data on an entity and its attributes. Microsoft Access is a relational DBMS for desktop systems, whereas DB2, Oracle Database, and Microsoft SQL Server are relational DBMS for large frame and mainframe mid-range computers. MySQL is a popular open-source DBMS, and Oracle Database Lite is a DBMS for mobile computing devices. A relational database organizes data in the form of two-dimensional tables. Illustrated here are tables for the entity supplier part showing how they represent each entity and its attributes. Supplier number is a primary key for the supplier table and a foreign key for the part table. There are different operations of a relational DBMS. Relational database tables can be combined easily to deliver data required by users provided that any two tables share a common data element. In a relational database, three basic operations are used to develop useful sets of data: select, join, and project. The select operation creates a subset consisting of all records in the file that meet stated criteria. Select creates, in other words, a subset of rows that meet criteria, while the join operation combines relational tables to provide the user with more information than it is available in an individual table. The project operation creates a subset consisting of columns in a table, permitting the user to create new tables that contain only the information required. What are the different capabilities of database management system? A DBMS includes capabilities and tools for organizing, managing, and accessing the data in the database. The most important are its data definition language, data dictionary, and data manipulation language. DBMS have a data definition capability to specify the structure of the content of the database. It would be used to create database tables and to define the characteristics of the fields in each table. A data dictionary is an automated or manual file that stores definitions of data elements and their characteristics. A data manipulation language is a specialized language that is used to add, change, delete, and retrieve the data in the database. This language contains commands that permit end users and programming specialists to extract data from the database to satisfy information requests and develop applications. The most prominent data manipulation language today is the Structured Query Language, or the SQL. How do we create and design databases? To create a database, you must understand the relationships between and among the data, the type of data that will be maintained in the database, how the data will be used, and how the organization will need to change to manage data from a company-wide perspective. The database requires both a conceptual design and a physical design. The conceptual or logical design of a database is an abstract model of the database from a business perspective, whereas physical design shows how the database is actually arranged on direct access storage devices. Illustrated here is how the query would be constructed using Microsoft Access. It shows the tables, the fields, and the selection criteria used for the query. Normalizing entity relationship diagrams. The conceptual database design describes how the data elements in the database are to be grouped. The design process identifies relationships among data elements and the most efficient way of grouping data elements together to meet business information requirements. To use a relational database model effectively, complex groupings of data must be streamlined to minimize redundant data elements and awkward many-to-many relationships. The process of creating small, stable, yet flexible and adaptive data structures from complex groups of data is called normalization. After normalization, the original relation order has been broken down into four smaller relations. The relation order is left with only two attributes, and the relation line item has a combined or concatenated key consisting of order number and part number. Database designers document their data model with an entity relationship diagram. Illustrated is the diagram and the relationship between the entity, supplier, part, line, item, and order. The boxes represent entities. The lines connecting the boxes represent relationships. A line connecting two entities that ends in two short marks designates a one-to-one relationships. A line connecting two entities that ends with a crow's foot topped by a short mark indicates a one-to-many relationship. It can't be emphasized enough, if the business does not get its data model right, the system won't be able to serve the business well. The company's system will not be as effective as they could be because they have to work with the data that may be inaccurate, incomplete, or difficult to retrieve. Understanding organizations' data and how they should be represented in a database is perhaps the most important lesson you can learn from this course. In conclusion, a business should and must invest in a reliable and well-founded database management system because it will streamline the different processes for an effective and efficient delivery of service to our customers as well as to those who work in the organization. With that, that ends my report. Thank you very much.
Go ahead, ma'am.
I'll be discussing the second part of Chapter 6, which is the foundations of business intelligence, databases, and information management, using databases to improve business performance and decision-making. Businesses use their databases to keep track of basic transactions such as paying suppliers, processing orders, keeping track of customers, and paying employees. But they also need databases to provide information that will help the company run the business more efficiently and help managers and employees make better decisions. If a company wants to know which product is the most popular or who is its most profitable customer, the answer lies in the data. In this chapter, we need to understand what are the primary tools and technologies for accessing information from databases to improve business performance and decision making. The challenge of big data is number one, massive sets of unstructured, semi-unstructured data from web traffic, social media, and sensors. Number two, data sets with volumes so huge that they are beyond the ability of a typical DBMS to store and analyze. Businesses are interested in big data because they can reveal more pattern and interesting anomalies than smaller data sets with potential to provide new insights into customer behavior and activity. However, to derive value from these data, organizations need new technologies and tools capable of managing and analyzing non-traditional data along with their enterprise data. Business intelligence, or BI, is a term used by hardware or software vendors and information technology consultants to describe the infrastructure for warehousing, immigrating, reporting, and analyzing data that come from business environment, including big data. A contemporary infrastructure for business intelligence has an array of tools for improving business performance and decision-making. These capabilities include data warehouses, data mart, Hadoop, in-memory computing, and analytical platforms. A data warehouse is a database that can store current and historical data from many core operational transaction systems. It also consolidates and standardizes information for use across an enterprise and provides analysis and reporting tools. A data mart is a subset of data warehouse in which a summarized or highly focused portion of data is placed in a separate database for use by a specific population of users, and it typically focuses on a single subject or line of business. Hadoop enables distributed parallel processing of big data across inexpensive computers. Hadoop consists of several key services, which are Hadoop Distributed File System, or HDFS, for data storage, and number two is the MapReduce for high-performance processing, which are used by Facebook and Yahoo. Another way of facilitating big data analysis is to use in-memory computing, which relies on a computer memory RAM for data storage. It can reduce hours or days of processing to seconds, and it requires optimized hardware. Lastly is high-speed analytic platforms using both relational and non-relational tools optimized for large data sets. Analytic platforms are now available as cloud services. 5 largest providers are Oracle, SAP, IBM, Microsoft, and SAS. In this chapter, we will discuss how to manage the data resources. We need to know why our information policy, data administration, and data quality assurance are essential for managing the firm's data resources. Setting up a database is only a start. In order to make sure that the data for your business remain accurate, reliable, and readily available to those who need it, your business will need special policies and procedures for data management. Excuse me. Every business, large and small, needs an information policy. An information policy specifies the organization's rules for sharing, disseminating, acquiring, standardizing, classifying, and inventory information. Data administration is responsible for specific policies and procedures through which data can be managed as an organizational resource. These responsibilities include developing information policy, planning for data, overseeing logical database design, and data dictionary development, and lastly is the monitoring specialist and end user group. Next is the data governance. It deals with the policies and processes for managing the availability, usability, integrity, and security of the data employed in an enterprise. Lastly is the database administration. Database administration is responsible for defining and organizing the structure and content of the database and maintaining the database. A well-designed database and information policy will go a long way toward ensuring that the business has the information it needs. However, additional steps must be taken to ensure that data in organizational database are accurate and remain reliable. This include the ensuring of data quality. Number 2 is the data quality audit, and lastly is the data cleansing or data scrubbing. Analysis of data quality often begins with a data quality audit. Data cleansing, also known as the data scrubbing, consists of activities for detecting or correcting data in a database. It also enforces consistency among different sets of data. That's the end of my report, sir. Thank you for listening po.
Okay, so as what our presenter mentioned, no, that the topic is focus on the foundation of business intelligence and databases, of course, and information management. Now, what we wanted to know, of course, is what issue arise when managing data resources in a conventional file environment, and how can a database management system address them, no? Organizations find it challenging not to arrange their data so that it can be easily accessed and to keep track of all the data pieces they need in a systematic fashion, no, using traditional file management strategies. It was permitted for various functional sectors and groups to and then independently create their own files. No? So the typical file management environment eventually gives rise, no, to issues including data duplication and inconsistency, software dependency, rigidity, lacks security, and lack of data availability and sharing. So as our first presenter mentioned, no, a database management system offers a solution to this issue by enabling the centralization of data and data management, giving organization access to a single reliable source for all of their data requirements. It reduces superflows and inconsistent files by using a DBMS. Another is, what are the main DBMS features and what makes a relational DBMS so potent? No? A DBMS firms, no, or a DBMS main feature are a data definition capability. So a data dictionary capability and a language for data manipulation. So the database's structure and contents are specified by the data definition capability. And the database contains information about the data, including the name, definitions, formats, and description of data pieces. No? And this information is stored in a manual or automated file called the data dictionary. So, a specific language for accessing and modifying the data in the database is the data manipulation language. So our presenter mentioned about Microsoft Access, and the most commonly used is the SQL, or structured query language. No? So due to its flexibility and accessibility, the relational database is currently used as the major method for organizing and maintaining data in information system. So data is arranged in relations two-dimensional tables with rows in columns. No? And each tables include information on a certain entity and its properties. So every record is represented by a row, and every attribute or field is represented by a column. So a key field is included in every table to enable retrieval or manipulations of record by uniquely identifying them. So if any two relational database tables share a common data piece, it is simple to combine them to provide users with the data they need. Okay? So why or what key tenets of database system should be followed? So a database must have a physical design as well as a logical design. So the database is modeled logically from a business standpoint. So the main business processes and needs for making decisions should be reflected in the organization's data model. When developing a relational database, the process of normalizations entails transforming large, unstable, flexible, and adaptive data structures into smaller, more manageable ones. No? We have, of course, what we call many-to-many relationship. It won't exist in a properly constructed relational database. And each entity's unique attributes will only be applicable to that object. In order to maintain consistency in the relational between connected tables, it will attempt to apply referential integrity constraint. And the relationship between entities o yung tables na tinatawag natin in a relational database is graphically represented by entity relationship diagram or yung tinatawag ng mga IT practitioner na ERD. Okay? Doon natin makikita kung, let's say, student number, common yun, naka-primary kayo sa, let's say, kung sa school, sa guidance, same sa library ang number, same sa accounting, same sa registrar. Okay? Naka-primary key siya. Okay? Another is, what are the main methods and technologies for getting information out of database to boost productivity in decision-making in business? Because we use databases for decision-making. No? So, to access and evaluate the data in databases, strong technologies are available. Because a data warehouse gathers recent and archival information from numerous operating systems and organizes it in a single database for reporting and analysis. Data warehouses facilitate online analytical processing, also referred to as a multidimensional data analysis, or online analysis, processing. And more complex data analysis is made possible by OLAP, which display relationship between data as a multidimensional structure that can be seen as data cubes and cubes within cubes of data. So, large data sets
particularly those found in data warehouses, are analyzed using data mining to discover patterns and rules that can be applied to future behavior predictions and decision making. And large, unstructured, text-based data sets are analyzed by enterprises with the aid of text mining tools. And web mining tools concentrate on the study of valuable patterns and data from the World Wide Web. No? Looking at both the architecture, okay, of website and the user behavior of those websites, as well as the content of web pages. So that the traditional databases can be connected to the web or web interface using middleware to make it easier to user to access the organization's internal data. And last, no, why is managing the firm's data resources reliant on information policy, data administration, and data quality assurance? A solid data model, database technology, and policies and processing for managing corporate data are all necessary for creating a database system. The upkeep, sharing, and utilization of information within the business are all governed by a written information policy. Because information policy, data planning, data dictionary construction, and data consumption monitoring are all responsibility of a formal data administration functions in a large businesses. Because they can result in errors in product pricing, customer accounts, and inventory data, as well as faulty decision regarding the firm's course of action. Data that is inaccurate, incomplete, or inconsistent cause major operational and financial problems for firms. No? Companies must take extra precaution to guarantee excellent data quality. And this include of utilizing database created to reduce duplicate and inconsistent data, enterprise-wide data standard, data quality audits, and data cleansing tools. So I think that's it for this topic.
Okay, so I think that's it for the topic number 6. Okay? So topic number 7 tayo.